TensorFlow's distributed execution framework. This framework enables the efficient distribution and coordination of computations across multiple devices or machines in a distributed setup. The framework is crucial for scaling machine learning tasks, accelerating computation, and handling large datasets efficiently. Let's dive deeper into the key concepts and features of TensorFlow's distributed execution framework. The first one is the distributed execution engine. TensorFlow's distributed execution engine manages the distribution and coordination of computations across worker nodes in a distributed setup. It includes several components and features to facilitate distributed training and inference. The first one is distributed sessions. TensorFlow provides distributed session objects tf.distribute.strategy that manage the execution of TensorFlow graphs across multiple devices or machines in a distributed setup. These sessions coordinate the placement of operations and tensors, handle communication between devices, and manage the synchronization of computations. Distributed optimizers. TensorFlow includes distributed versions of popular optimizers, example Adam and SGD, that are designed to handle distributed training scenarios efficiently. These optimizers implement techniques such as gradient averaging, gradient clipping, and asynchronous updates to optimize performance and convergence in distributed setups. Fault tolerance. TensorFlow's distributed execution engine includes mechanisms for handling failure and retries in distributed setups. It provides fault-tolerant communication protocols, checkpointing mechanisms, and recovery strategies to ensure that computations continue even in the presence of node failure or network issues. Second one is the distributed training strategies. TensorFlow supports various distributed training strategies to accelerate model training and handle large datasets. Some common distributed training strategies include data parallelism. In data parallelism, the dataset is partitioned across multiple devices or machines, and each device computes gradients independently using a subset of data. Gradients are then aggregated across devices to update the model parameters. TensorFlow's tf.distribute.mirror strategy is commonly used for data parallelism. Model parallelism. In model parallelism, different parts of the model are computed on different devices or machines. This is useful for large models that cannot fit into the memory of a single device. TensorFlow's tf.distribute.strategy provides support for model parallelism by allowing developers to specify custom devices placement and execution strategies. Pipeline parallelism. Pipeline parallelism divides the computation graph into stages, with each stage running on a separate device or machine. Data flows through the pipeline and computations are overlapped to improve throughput. TensorFlow's tf.distribute.strategy can be used to implement pipeline parallelism by partitioning the computation graph and coordinating the execution of stages across devices. The third one is deployment and configuration. Deploying and configuring distributed TensorFlow setup requires careful consideration of factors such as network topology, device placement, communication overhead, and resource allocation. TensorFlow provides tools and APIs for configuring and managing distributed setups, including tf.distribute.strategy. TensorFlow's distribution strategy API tf.distribute.strategy provides a high-level interface for distributing computation across devices or machines. It supports various strategies such as mirrored strategy, parameter server strategy, and multi-worker mirrored strategy, allowing developers to choose the most suitable strategy based on their requirement and deployment environment. TensorFlow Extended (TFX). TensorFlow Extended provides end-to-end tools and platforms for developing and managing production ML pipelines, including distributed TensorFlow setups. TFX includes components for data ingestion, pre-processing, training, evaluation, and serving, enabling developers to build and deploy scalable and reliable machine learning systems. TensorFlow's distributed execution framework is a powerful and flexible solution for scaling machine learning tasks across multiple devices or machines. By leveraging TensorFlow's distributed training strategies, execution engine, and deployment tools, developers can build and deploy distributed machine learning models for a wide range of applications, from training deep neural networks on large-scale datasets to deploying real-time inference services in production environment. Understanding the key components and features of TensorFlow's distributed execution framework is essential for effectively harnessing the power of distributed systems and scaling machine learning workflows to meet the demands of modern applications.